So now we're on question 3 about the Scranton Strangler. So the Scranton Strangler, a masked criminal, is on the loose in the small town of Scranton, which has a population of 1,000. Volunteer Sheriff Dwight has been assigned the role of catching the Strangler. From witness reports, the police are certain that the Strangler is left-handed. Meanwhile, anonymized records from Scranton's primary care providers show that 1 in 20 Scranton residents is left-handed. Okay, so off the bat, the information we know is that the total population is 1,000. There is 1 strangler, and 1 over 20 people are left-handed. And we also know that the strangler is left-handed. Okay, so part A is suppose Dwight calls a random phone number in Scranton and a person answers the phone. What is the probability that the person is the strangler? So this question it's just asking basically how many stranglers there are divided by the entire population. Because since he's calling a random phone number, every single person has an equal chance of getting called. So there's 1 strangler out of 1,000 total people in Scranton. So the probability is just 1 over 1,000. Okay, so now part B and C are about conditional probability. Okay, so part B. Suppose Dwight bumps into a random Scranton resident at the gas station and notices that they are left-handed. What is the probability that they are the Scranton Strangler? So here, we are given that the person is left-handed, and we want to know what's the probability that they're the strangler. So in order to do this, let's draw a tree diagram. So we have, let's go here. This is just a person, the person who he finds at, or any person in Scranton actually. So this is, you are the strangler. Let's just leave it at STR. And then this is not the strangler. Okay, so the probability of you being the strangler would be 1 over 1,000, because there's 1 strangler in the entire town. Again, sorry for the handwriting. Then the probability of you not being the strangler is 999 over 1,000. Basically, everyone except the strangler is obviously not. Okay, so now the second condition that we're analyzing under is left-handed versus right-handed. So this option is left-handed, and this one is right-handed. Left-handed and right-handed. Okay, so since we know for a fact that the strangler is left-handed, the probability of being left-handed given that you're the strangler is 1. It's just guaranteed. Similarly, the probability of being right-handed given that you're the strangler is 0. Because given that you know that the strangler is left-handed, they can't be right-handed. You're one or the other, right? So if you're not the strangler, then your chance of being left-handed is 1 over 20, as the question states. And then the chance of not being the strangler, the chance of being right-handed would be 19 over 20. Okay, so what we want is the probability of strangler given that they are left-handed. And we use this bar symbol here to symbolize the word given. And so how we can calculate this is that we can say we want to know the probability that they are the strangler given they're left-handed divided by the probability of being the strangler given you're left-handed plus the probability of being left-handed and not being the strangler. So basically we want to take all the left-handed people and see the probability of one being the strangler. So the formula for this is Bayes' rule. So we want the probability of being the strangler and being left-handed. So that would be 1 over 1,000 is the chance of being the strangler times the probability of being left-handed given that you're the strangler is 1. And so we're going to divide this by 1 over 1,000 times 1 plus, and then we want the chance of not being the strangler and being left-handed. So that would be this chain right here. So that would be 999 over 1,000 times 1 over 20. And so you don't have to simplify your math because it's just this answer right here. And just to do a sanity check, if you simplify this out, the answer you'll get is 1 over 50. And this answer makes sense because there are 50 left-handed people in Scranton, and we can figure that out by saying 1 over 20 times 1,000 people is 50 left-handed people. And so the strangler has to be one of those 50 people, right? So the probability of strangler given left-handed is just 1 over 50 if we do it that way. Okay, so now part C. Suppose Dwight has a coworker named Creed, who he doesn't trust. Before observing Creed's hands, Dwight thinks there's a 10% chance that Creed is the strangler. Now, suppose Dwight discovers that Creed is actually left-handed. Given this new information, what is the probability that Creed is the strangler? Okay, so this is a very similar problem to part B, but instead we have a different starting chance that Creed is the strangler. So we'll make a new tree diagram. So we have Creed right here, and then we have strangler and not strangler. But this time, we actually have guesstimated probabilities that he's the strangler. So Dwight thinks that there's a 1 over 10 chance of him being the strangler. So we're going to put 1 over 10 there. And then that means that there's a 9 over 10 chance that he's not the strangler. So now we can add our left-handed and right-handed. Okay. So again, if he's the strangler, it's a guaranteed chance of being left-handed, or left-handed. So 1, and then 0 for right-handed. Then for not the strangler, we have left-handed and right-handed again. And then here, our chances are the same as before, which are 1 over 20 chance to be left-handed. Oops. So 1 over 20. And then 19 over 20 chance of being right-handed. So now we can apply Bayes' rule again. So we want the probability of being the strangler given left-handed again. And so now we can calculate this in a similar way to the previous question. So we want the chance of being left-handed and the strangler is 1/10 times 1. Divided by 1/10 times 1 plus this path here of being left-handed but not being the strangler. So this would be 9/10 multiplied by 1/20. And that lines up with this answer right here.